In this problem, we are again looking at paired data. Now, they did not actually give us the data, but we are looking for D, the difference of classical minus silence, where the two scores are done by the same person, right? It's the same task in silence by the same person. So since we're talking about the same person, they are directly linked and they are paired. And so here's our hypotheses they want us to test. Now, here's the thing is, if we don't have the actual data, we can't use the paired version here, because this is only if we have the data. In this case, whenever we have the actual statistics for the differences, we end up with a single mean for the differences. So instead of x bar, we have d bar, which is the mean of all the differences d. So really, it just turns into a one sample t-test on the differences. So we're going to run this as a one sample t-test. So on here, t, one sample, with the summary statistics, instead of the sample mean of a single sample, we're looking at the sample mean of the differences. So in this case, 16. For the sample standard deviation, we're just going to take the sample standard deviation of the differences, which is 23.8. And our sample size is the number of differences that we have, not the number of measurements, but there were 8 people that have 2 measurements each, but it's the 8 people that we're going to be using. So n is equal to 8. And again, we'll just compare it to our hypotheses that's given. So again, we're looking at the mean of the differences is 0, because that means no difference, and we're looking specifically for greater than. Compute. And here we go. We have our test statistic, 1.901. And our p-value is this one right here, 0.0495. Now we must compare this to our alpha. Our alpha is 0.002. And so since our p-value is greater than 0.002, we are greater than alpha. And again, a larger p-value means we're going to fail to reject the null hypothesis. And what does this mean? We're failing to reject it because there's not enough evidence to reject it. So we find that there is not sufficient evidence to warrant rejection of the claim that the mean is greater than 0. No. We're trying to reject the fact there is not sufficient evidence to support the claim that the mean difference is greater than 0. So we don't have enough evidence to reject the null, which is that they're the same, and that means there's also not enough evidence to show the alternative that the post-test is greater than the pre-test.